It's all around us. It's in the air that we breathe. It's on the ground that we walk on and the clothes that we wear. Matter's everywhere. And it's also important that it makes up almost everything. We need matter so that we can live and breathe. Now, matter is made up of little particles called atoms. But matter doesn't just stay the same. Matter changes. So we need to know how it changes. We need to know what it is. So let's find out.
Welcome to the Changes in Matter notes. In these notes, you will learn what is a physical change, what is a chemical change. You'll learn about the three states of matter and how they're different, and what are those changes in state and how they occur. First of all, what is a physical change? A physical change occurs when a substance changes only form or appearance. So anytime you change a substance without actually changing what it is, that's called a physical change. So in this list of examples, think about ripping paper.
Check it out. Paper. Yeah, it's just some paper. What would happen if we ripped it in half? Oh. Is it still paper? Yeah. What if we ripped it in half again? Still paper? Oh, that's still paper. So this is a physical change. It's still the same substance. The paper is still paper. And if we keep ripping it, that is still paper. No matter how small we rip it up, it's still going to be paper. That is a physical change. Oh no! I spilled some water. Whatever shall we do? I'll wipe it up. That is a physical change. There's no difference in what substances there are. There's a paper towel still. There's water still. It's still water. It's still a paper towel. And I could even squeeze the water out of it. Still water. Still paper towel. It's a physical change. Nothing actually changed what it was. Salt and water. I can add some salt to this water. Stir it up. This is a physical change too. Is it still salt and water? It is still salt. And it is still water. It has not chemically changed into anything else. It is still water. And there's still salt. It's just dissolved. That's all. You could take the salt back out of this by boiling off all the water. It's a physical change.
So what is a chemical change then? Well, a chemical change in matter actually changes what that substance is. It's no longer what it was before. It's something new. And when something new is made, chemical bonds are either broken or they're formed. And there are a whole bunch of examples. So anytime there's a chemical reaction, that is a chemical change.
As you go around your kitchen, there are so many changes in matter. Let's look at some chemical changes. How do you like your eggs? Cooking is almost always a chemical change. You can't uncook an egg. That is one piece of evidence that it's a chemical change. As you cook things, you change the molecular bonds of the food. Cooking often degrades or joins together different elements in different combinations. So we get a chemical change. Check it out. The natural gas is being burned. It's changing into carbon dioxide as it burns. This is a chemical change. Anytime you see burning, just like this, that is a sign that there's a chemical change happening. The matter is changing from one form into another.
There are three states of matter: solid, liquid, and gas. There's also a fourth state called plasma, which is ionized gas, and an example of that is lightning. So let's take a look at the three main states of matter. Solids. solids have a definite shape and a definite volume. It's things that you can actually hold on to and measure, and these have the least amount of movement of the particles. The particles are tightly packed and just vibrate in place. These are often in a crystalline shape.
Here's some solid H2O, also known as ice. It is solid right now, but it will soon melt and become liquid water. Solids have definite shapes and volumes. We could measure the volume of these if we wanted to. And solids,
liquids, have a definite volume, but they'll take the shape of the container that you put them into. So these move around each other, they have more kinetic energy, they're moving a little faster, and they're also a little further apart than in a solid.
That ice is now melted. We can take it, and it will take the shape of whatever container we place it into. It's a liquid.
In a gas, there is no definite shape or volume, and these gases will fill whatever container they're placed into, because these particles are moving at high speed, lots of kinetic energy, and they can bounce off each other. They're pushing on all sides of whatever they're placed into.
This is a balloon. It has gases in it. A lot of the gases are nitrogen, carbon dioxide, oxygen, and they're inside the balloon pushing out on it. That's why I'm able to push down on it, and I feel resistance. It pushes back out. A gas will push out on a container, and gases have no definite shape and no definite volume. The particles in a gas are going very fast, and they're pushing out on all sides of this balloon. That way, they actually fill the container that they're placed into. That's how balloons work. It's a gas.
So what are all those changes in state? Some of them you're familiar with, like melting. Right? We're all familiar with ice melting from a solid to a liquid. And you may be familiar now with a solid turning into a gas, which is sublimation. And all of these we can experience almost every day, other than sublimation and deposition. Well, how do these changes in state occur? Well, it has to do with energy and heat either being absorbed or released. So to take water that's liquid and change it into water vapor, a gas, you need to add energy. Energy is going to be absorbed by it. That heat is going to be absorbed by the water, just like you have to put it on the stove to heat it up, and it'll change into a gas. It'll either boil or it'll evaporate. And you imagine if you want to take liquid water and you want to turn it to ice, you need to take heat away from it. So you're going to be releasing that heat. And when that heat is released, those particles go slower and slower because they have less and less energy, and they'll become a solid.